That part we know. We also know that we have to point to this thing. And Dr. O'Neill says if you can point to it, half the problem is done. In that case, to the field, which is R primed, I'm sorry, to the source point, which is R primed, that's going to be A. Is it A over 2 or is it A?
A over 2.
It's A over 2. I hat. Yep. No, it isn't. It's A. This is minus A to plus A.
It's minus A. Oh, yes. 2A.
This is 2A, right?
Yeah.
So I go here, then up.
Yeah.
So to point to it, yeah. So to point to it is that's the mistake I made in my notes. YJ hat. Yes, that's what I'm talking about. The field point is ZK hat. Field point's out here, yes? So I put all that together. Really what this is, when you don't have such a beautifully simple geometric situation, is DL cross R minus R prime, correct?
Yeah.
Over R minus R primed cubed. That's what that is. Now I'm just doing this leg, right?
Right.
I take all these three. Marina, what's the matter?
But then
I thought you did this problem.
we did, but he's asking a question.
Well, was it Matt that wasn't here that day?
No, I was here. I was just wondering.
Alright. What are you wondering?
The R.
This R?
Yeah. Why do you have a I hat plus Y J hat?
R prime down.
Well,
R primed. That's R primed.
Okay, so you're not projecting back on the axis.
No. What that is, look, Matt. KQ over R hat. Remember that? That's the electric field from a point charge, yes?
Yes.
One of the extensions we did, if the point, this is at the origin, if the thing's at the origin. But if the thing's not at the origin, we have to go here and then do that.
Okay.
So we did KQ, this is one of the first things we did in this class. Remember that? That's what that is. Okay.
So you're not turning your back on us, you're turning your...
I'm coming forward.
Yeah.
That's right.
Alright.
Alright, so this is DL cross, this is what we got. A I hat, let's put this in actually, as DY, J hat, cross, I like doing it again, there's something else I wanted to say about it. AI hat, what's the first thing first? ZK hat, right? ZK hat minus AI hat plus YJ hat. That is R minus R prime, right there. That's what that is. This comes out to be then DY, Z, J cross K. What's J cross K?
Is J cross
That's
K.
K.
Wait, J
It's
cross
I
I got it.
Alright.
I know that stuff.
Minus
We make sure now.
J cross I is minus K hat,
Yeah.
right?
Yep.
So that gives me a minus, which is plus A dy K hat. Then J cross J is 0. Now here's the point that was of interest as you were doing this problem. You would anticipate that the magnetic moment points in which direction because it's a closed loop and you got a lot of symmetry. Because, and here's another way to think of this. Just because I do this better than most people who do, I'm going to point this out. You take your fingers. You see your fingers? Right hand. Grab this branch. You see my fingers curling out on the other side? That points that way, right?
Right.
Top branch. That points that way. Side branch. That points, oops.
Points.
Yeah,
Out.
Yeah, that point comes out. So all four of those come out. So you know that's going to be on the symmetry axis. So the question becomes, what the heck, what's this thing doing here? And it cancels on the other side. On the other side, of course, what I will have is DL. This is right leg. Here's left leg. DL, cross the same thing, will be equal to minus DY, J hat, cross, this guy is still ZK hat, I think, isn't it? Yep. And then this will be minus A, I hat, plus Y, J hat. Have I got that right? I think so. So this becomes negative dy z I hat. This is still 0 out here, j hat cross j hat, and I still get plus minus, 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 minus. That's 4 minuses. 1 minus. But there's more. A second minus. But there's more. A third minus. Where's the last minus come from? J cross I is minus K hat. So you got 4 minus signs you got to take care of. That's the most I've ever seen in my entire life. Y, A, K hat. These two add. I don't have to do these, right? It's the same thing. The same thing. So what I can do is, immediately when I add these up, I can now make the magnetic field in the middle 4 times mu naught I over 4 pi. And then I have an integral to do from minus A over 2. So minus A to A dy A K hat. Let's see what's on the bottom now. What's on the bottom is this guy in magnitude. Let's figure that out. The magnitude of that guy will always eventually end up looking like this. Every single time. And it will be, in fact, z squared. Look, just very quickly, look up here a second. It's ijk, there's no mixing of the 3 terms. Now, one of the reasons I think this was a good problem to do in ISI is, obviously you learned this, but it makes you use the formula for an integral a little bit outside of what was your comfort zone. Maybe you had seen it before, maybe not. Down here then I have a squared plus y squared plus, let's write this a little bit differently, z squared plus y squared to the power of 3 halves, correct?
Yeah.
I think I got everything right. Anybody know this integral off the top of their head? I don't. You know that? He knows it off the top.
We know where it's at.
We know where it's at. That's all that counts. That's all that counts. That's all that counts. And when you do this integral, this whole thing, just because it's A doesn't mean it's A in the back of the book, right?
Right.
This is all
X.
okay. I guess he calls it A squared plus U. What does he call it?
He calls that A.
He calls it. So we'll call this
like
beta squared plus y squared, correct?
Yeah.
You integrate this, and you get the answer. Okay, I'm going to write that answer down to do part B and part C. Nobody had trouble with the integral, or did the integral present a difficulty?
No, we discovered that's what we needed to do. So we went to the back of the book.
Well, that's the whole point of it.
You
You know what I
showed us
mean?
2 days before that, like you had to use that one 2 days before.
Okay.
So
Okay.
it's
What did I use that one 2 days before? Oh yeah, when I did the No, you're right. Absolutely. So what I have for part B is I need this. I need the answer, which is 2 mu naught. Mu naught. This is the magnetic field in that answer. I'm glad everybody got that. Hour and a half. That's not bad. That's not a bad effort, Kevin.
Well, the hard part was just the Cartesian. We couldn't figure out DL.
Yeah.
Now you know what it is.
Yeah.
You know, it doesn't matter how many times I say it. You got to do it for yourself. Just like anything else, you got to do it for yourself.
Yeah, well, R. We couldn't.
But you know what? You had trouble with that since the very first day. You had trouble with that since the very first time we wrote it down. Because you were the one asking me after class, what the heck is this D? Is it phi hat? Is it RDP? Right out here. So somehow now, hopefully, it takes hold. And you'll probably be able to use it in your job interview.
Yes.
I finally learned where DL is in my magnetic class.
What can I bring to your company, sir? I know what a current element is in vectorial notation. A squared, and let me tell you, not everybody knows that in the world.
And if you use such big words, it'll crush them even more.
Yes, it will.
All right.
Those big words.
That's it, right? We good?
Yep.
Okay. So the first thing he wants here is what happens at Z very, very far away. When Z is much bigger than A. What I'll do here is the following. I'll write this as 2 mu naught I A squared. Is that Kamani who just walked in?
Yeah. Of course.
And then I'll take here pi. That's Z squared. Z squared is much bigger than A squared.
Yeah.
Yes.
I don't even see an A squared. It's not even there. A squared.
Okay, my question right there was, why we don't take into consideration A squared on top?
Because you'll see in a second.
Oh, it's because it's not comparable
Well,
to
because
Z,
not.
right?
Thank you. All right. Thanks for spoiling the whole suspense of it. All right. Now I feel like why don't you tell me how Avatar comes out in the end?
It was
They
great.
all
It
die.
I don't care how Avatar
was
comes out.
so good.
One of the avatars gets pregnant with a human baby.
Wow.
What?
There you go.
It was good.
It's because this A is part of a point It's two answers. First of all, yes, you're not comparing it. If you did, you would be out of business because Z is bigger than A, B 0.
Right.
He wants to look at the op. Okay, that's one answer.